We've demonstrated one example of a line integral of a scalar function. And I want to write down a couple of general statements so that the line integral, and there's something, okay, line integral of f of x, y, z along the path that I'll represent by r of t, a less than or equal to b, and I've done it again, should be a less than or equal to t less than or equal to b. I'm going to repair that. Okay, this line integral is the integral from a to b of f of x of t, y of t, z of t, where x of t, y of t, z of t are the components of our r of t vector, the I, j, and k components, which could also be given by parametric equations, times r prime of t times the magnitude of r prime of t, and I'm going to have to dt, and I didn't quite get that in. Someday I hope to learn to be able to judge how much space I've got left. I seem to always be too optimistic. Anyhow, this would be the meaning of the integral, and it should be fairly well illustrated by this example, and the process is always pretty much the same. If you have the x of t, y of t, and z of t functions, then you have the r of t position function. If you have the r of t position function, then you can write down your parametric equations x of t, y of t, and z of t. One interpretation of this sort of an integral f of x, y, z is length density, meaning mass per unit length, then the path has mass, which is the integral. And I'm going to go to the fine point marker. I can write this a little more compactly. From a to b of f of x, y, z ds, where ds would be your magnitude of r prime of t dt. So this could be written up here as a ds. No, I'm not going to make that annotation. I'll just leave it down here. And you can see this in any standard text. These are fairly standard notations. For the special function, well, let's see now. If f of x, y, z is identically equal to 1, then the integral from a to b of f of x, y, z and I'll just abbreviate that, f ds is equal to the integral from a to b of 1 times ds, which is just the integral from a to b of ds, where ds is the magnitude of r prime of t dt, and this equals the arc length of the path between the t equals a and t equals b points. Okay, let's get this whole page where it's visible. And I've also patched up the bad looking D to a slightly less bad looking D. Okay.